Kia ora, everyone. Okay, we're here to talk about Arctan. What is it? Why is it? Why do we need it? Okay, here's the scenario. You have a homing missile, and you want it to follow the player as the player is moving. But you don't want, like what we had in our previous video, where one sprite was following another one. You don't want it to change speed. You always want it to have the same speed. Or maybe another scenario is you want a sprite to face and look at the mouse or another sprite as it's moving across the screen, or perhaps you want a homing beacon, or you want a zombie which is chasing you down, which is following the player as the player is moving, and it always travels at the same speed. What is the solution to this? Whoa. Okay. Here's you. And here is, let's say here's a coin, which is the mouse. And we want the player to always want the money, so they're always going to face the money, and they're going to travel towards it. Now, what did we look at last lesson? Last video, we looked at using sine and cosine in order to set circular motion. It's going to be something a little bit similar here, where you want their direction of motion to be towards this thing here. You know the X and the Y position of the player. You know, of course, the X and Y position of the coin, mouse X, mouse Y. So you want to be able to use those two things to set the velocity, the speed of the player in that direction. Okay, in order to do that, what you'll need is this angle. We know how to use that angle to then set the velocity in the X and the Y component, but how do we find that angle just from this position and that position? The answer is Arctan. And in fact, there's a slightly better version of Arctan, which was introduced way back in the Fortran days. So go and thank the old school programmers who developed this stuff. So there's a function called atan2, which will give you this angle. And how atan2 works is if you take the difference in the y, this y position minus this y position, and you give it the difference in the z, difference in the x, then this position minus this position, it will give you this angle back, and then we know how to use that angle to give it the velocity in the right direction. Okay, let's work through it. Oh, my background's looking a bit interesting at the moment, but that's okay. We'll ignore it. No, that's from last lesson. Where am I? We're going to Arctan2. Here's what we're after. Let's run this. Let's boot this up. As you can see, my mouse is the coin. My player is not only facing it, but is also constantly moving towards it. And at a constant speed too. This isn't like lerp. The player isn't lerping towards it. Player is actually just moving towards it at a constant pace. Pretty quickly, but at a constant pace. So if you wanted an enemy with a constant pace that your player could always outrun, you'll need to do it in this way. And if you want that rotation as well, you'll need to do this. If you want it to look good, like the sprite to actually turn, like a homing missile or something, you'll need to do this as well. Okay. Let's dig into it. Where are we going to go from? Let's go from our let's go from our coin. The last video. Where was it? It was circles. Okay. Let's go from circles. Let's make a copy of it. Duplicate, copy, and paste. And let's call this one arctan. Okay. So this one's arctan. Great. So we've already got sine and cosine that's going to be necessary for later on. Keep that in there. Let's get rid of anything to do with our moon. Don't need our moon today. Don't need the radius or the angle. Well, let's leave the angle, but let's get rid of the radius. Okay, anything to do with the moon is going to go bye-bye. And let's get rid of that one. And let's probably get rid of that too and just pass on our update function. Get rid of our moon and bring back in arcade.render. Okay. We've still got our coin is there, but we're going to set our coin to our mouse motion. Now you remember how to do this. What do we need to do? We need to make a define on mouse motion. Whoa, don't use the IntelliSense. Well, actually, maybe. Let's use the IntelliSense version. On mouse motion, we'll just tidy it up. Get rid of the return. Get rid of the annotations here. The colon, everything. The colon to the comma. We don't need that. We just need it to look like this. So that's what we're after. Define on mouse motion. We're going to set self.coin.centerx to x and self.coin.centerY is going to be set to y. Okay. Cool. Let's make a player. Self.player is going to equal arcade.sprite, a new arcade.sprite. Its picture is going to be character underscore idle.png. Let's reduce it down a little bit. 0.7 again. 0.7. Lovely. Okay. We need to give our player an initial coordinate, and self.player.centerx is going to equal, put her in the middle. No, let's put it down the bottom somewhere. 100, 100. Should have called it character, but that's okay because we're not really the player at this point. Okay, is that 100, 100? The coin can, the coin can be wherever the coin can be. You can leave that as it is or set it to 0, 0. It won't matter because as soon as you move the mouse, it's going to be there. Player's not showing up. We're not showing the player at the moment. Great, let's fix that. I try to make sure that you can see as much of my code as possible, but while still actually being able to read it on YouTube, so that you can still follow along. So here we go. On draw, self.coin.draw, self.player.draw. Okay. Great. How do we get that motion now? How are we actually going to change the player's motion each and every frame so that so that it's going to move towards the coin? Let's split this into two problems. Let's sort out the facing the coin first, and then once we've got that, we'll know that we'll be ready to move towards the coin. So each of your sprites has a property called angle, which is their rotation in space. How much they're rotated, what direction they're facing. If you give it a property of 0, they're facing up the normal way, like the PNG was. If you give it 90, boom, they've turned. 180, of course, flipped on its head, and that's in degrees. So let's go on update. Self.player.angle is going to equal what? Let's just do something silly just so you can see what it does. Let's actually put it plus equals 1. Okay. What do you expect is going to happen here? I expect to see a player just doing the old hooty hooty. There we go. Spinning around. Cool. Now you can see what that does. How do we get this to make sure that we're facing the mouse? Okay. Well, we know that the coin is at its center X, center Y is at where the mouse is, so we can make it that. But we need to use arctan somewhere in order to get that angle. Okay, so it's actually going to be equal to the atan2 in particular. Arctan2 is an improved version of that arctan function. It's not the one your calculator will be using. This is one that us coders use. It's a little bit better, a little bit more efficient, and makes it's guaranteed to work. You don't end up with any funny errors like you can do with the normal arctan version. That takes the difference in the y's and then the difference in the x's. It's flipped over to what you might expect. It's y, then x. And the difference in the y's is, let's go, diff y is going to equal self dot coin dot center y minus self dot player dot center y. Ooh, got some flies, got some bugs. Okay, cool. The difference in the y is that. And guess what the difference in the x is? Diff x is going to be, all good mathematicians out there would actually use delta x or dx, the change in the x, but that's okay. We're going to use diff, so it's a little bit more obvious what we're talking about. Diff y, diff, whoa, what's happening? Diff y, diff x. Cool. Let's see if that works. Oh, it's moving a little bit. Can you see that? Oh, we are moving, but not very much. So something's going wrong here. I wonder what it is. And the answer is arctan, and in fact sine and cosine, they work in radians, and that's what all normal sensible people should work in all the time. But for whatever reason, the angle here is actually set in degrees. So how do we change that? You can go through and use a formula or write your own little function to change radians to degrees. But actually there's an inbuilt function, and you should use that whenever possible. So let's go import, please, degrees from math import degrees. And so down here you just say degrees. Hey, look at that. Our player is now always facing the coin. And let's say you were using a a roguelike or you're using a top-down, you could actually just say if the angle's over a certain amount, turn this way. If the angle's over a certain amount, turn this way. If it's over a certain amount, turn that way as well. So you could have it sort of in that north, south, east, and west kind of version as well. Okay, you don't necessarily have to have it rotating the whole way. It looks a little bit silly like that, but you can change that later on. Okay. Cool. What's next? Let's get that motion happening. So we've now got that angle. So let's go self.player dot change x is going to equal our velocity, whatever our velocity wants to be, which is probably, I don't know, 5 times the cosine of self.player.angle. And self.player. By the way, this is going to be wrong. See if you can spot why it's wrong before we figure it out together. Change y is going to be equal 5 times the sine of self.player.angle. Let's check it out. Ooh, we're not actually... it's another reason why it's wrong. Every time I say that, there seems to be multiple reasons. So we're not actually adding that change into its position because we're not calling self.player.update. And let's do that. Self.player.update. And that will actually automatically use that change x, change y property and put it into the position, right? There we go. Oh, wonderful. Whoa, okay. That's a bit different. What about when I move it? Whoa, what is happening? Oh, God. Oh, it's frozen. Ah. So it's got some motion. It's kind of working, but it's a little bit buggy at the moment. Not quite what we're after. Okay. What's the answer? Well, have you figured it out? It's because cosine and sine don't work in degrees. They work in radians. Again, like all sensible people should all of the time. We've converted our angle into degrees just because that's what Python Arcade was expecting. I also suspect that somewhere under the hood, I'd like to be, maybe I'll be proven wrong here, but I'd think that somewhere under the hood, that would be converted back into radians so that they can actually do some proper maths with it. But we've converted it to degrees here. We have to convert it back, or alternatively, we could calculate that arctan and then only convert it into degrees when we needed it. So we could say, we could just get a bare new variable there called angle. Calculate the arctangent there. And then we could say the player's angle is equal to that angle in degrees. And here, the change is equal to the cosine of that angle in radians. And it's equal to sine of the angle in radians. Radians, the best. Degrees, not so the best. All right, let's check that out. Ah, just magic. And there you go. We now have a following, consistently moving person. And again, you could use that in all manner of different ways. Anytime that you want something moving towards something else, an enemy doing that, or a missile, or a projectile, or a fancy bonus arrow that you fire once in a while that can home in on something, or that you have to avoid. There you go. That's it. that's using the arctangent to get some sort of homing, following, rotating behavior. When you know 2 points and you want one thing to face or move towards another point. Arctangent. We'll see you on the next one.